the Oort cloud. And every once in a while, one of these comets in that Oort cloud somehow comes in and starts circling around our sun. And that is why we still have long period comets. Now, there's some problems with the Oort cloud. One, it's never been observed. It's a claim with no observable evidence. There's no evidence that it really exists. And third, there wouldn't be enough mass for a hypothetical Oort cloud. Because by the evolutionist's own model, as the solar system is being formed, there are tremendous collisions of different masses going on out there. So many collisions, there would not be enough mass left to form an Oort cloud. So 3 problems right there for the existence of the Oort cloud. Well, let's take a look what some scientists have to say about the Oort cloud. Here's Don DeYoung, who has his PhD in physics, writes in his book, Astronomy in the Bible. And he says, the existence of the Kuiper Belt and the Oort cloud of comets has not been verified. Perhaps there is an alternative. And he says, the presence of comets may be evidence that the solar system is not as old as is often assumed. Now, notice he talks about the Oort cloud in here, but he also mentions another cloud called the Kuiper Belt. The Kuiper Belt is that ring of comets that's somewhere around Neptune that is supposed to be feeding the short period comets. Those comets that circle around our sun every 200 years or less. Now, we have seen some objects in this Kuiper Belt. We call them Kuiper Belt objects. There have been about 600 of these objects observed. But here's the problem. Here's the problem. You see, when we see these comets circle around the sun and go by our planet, about the largest size we ever see is about 10 kilometers in diameter. We never see anything bigger than that. But every object we have observed in this Kuiper Belt is at least 100 kilometers, up to 100 to maybe up to 500 kilometers in diameter. If we were to see an object of this size pass by our planet, it would be a tremendous spectacular vision. But we never see anything that big. They're always very, very small. So there's no evidence that the Oort cloud exists. It's never been observed. And the Kuiper Belt also does not solve the problem for the short period comets. Now here's another gentleman, Timothy Ferris, wrote a book called The Whole Shebang, a State of the Universe Report, 1997. Now, this book is actually used as a text in many universities as they're part of their astronomy course. And this is what he has to say. Though the Oort cloud has yet to be observed, the theory accounts so well for the distribution of comets' orbits that most astronomers today accept its existence. Now, doesn't that sound like faith? Let's take a look at the definition of faith here. And it says, an unquestioning belief that does not require proof or evidence. Isn't that the same thing the scientists are saying about the Oort cloud? We accept its existence even though we can't observe it. Folks, that is faith. And they're teaching that faith in our science classes today. Now here's another gentleman who has a comment about the Oort cloud. This is what he says. Many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution. Yet there is not yet a shred of direct observational evidence for its existence. Now, who said this? Well, it wasn't a creationist. It was Carl Sagan. Carl Sagan, a prominent evolutionist, astronomer, made this statement that there's not one shred of evidence for its existence. But yet, the evolutionists continue to teach it in our classes to force a faith system on our students. Here's another gentleman, Dr. Danny Faulkner, who has his PhD in astronomy. He writes in the Technical Journal an article called More Problems for the Oort Cloud. And he says this, since it cannot be detected, the Oort cloud is not a scientific concept. This is not bad science, but non-science masquerading as science. The existence of comets is good evidence that the solar system is only a few thousand years old. Evidence for one position is support for that position and evidence against the other position. We have seen several evidences right now for a young solar system. Let's look at a third, the age of the sun. Now, what does the sun do? How does it do what it does? Well, it goes through something called thermonuclear fusion, turning hydrogen into helium, converting hydrogen into helium. Now, as this process is going on, the core of the sun should alter, and the sun should go brighter with age. Should go brighter with age. Now, think of this. As it's growing brighter with age, that means it's getting hotter and hotter out here. Now, if the sun was 4.5 billion years old, as the evolutionists claim, the sun should have brightened by about 40% since its origin, 4.5 billion years ago. In other words, we should be about 40% hotter today than 4.5 billion years ago. Now, what does that mean? Well, the scientists today accept that the average temperature on this planet is about 59 degrees Fahrenheit or 15 Celsius. That is the average temperature. And they agree that's been about the average temperature for billions of years. Now, they believe we also have undergone different ice ages and different climatical changes. But the average temperature over this time has been about 59 degrees Fahrenheit. Now, let's go back in time. According to the evolutionists, life began about 3.5 billion years ago. Now, in order to have this life originate by natural processes, they require heat, a lot of heat. But think of this now. If we were to go back about 3.5 billion years ago, that would mean the sun would be about 25% less bright than it is today. And putting the sun at 25% less bright than it is today would mean that the sun would be about, the average temperature on this planet would be about 32 degrees cooler than it is today. So if you take the average temperature, 59 degrees, subtract 32 degrees, we have an average temperature on this earth 3.5 billion years ago below freezing. But what did the evolutionists require for life to originate by natural processes? Heat. But this entire planet is frozen. It doesn't work. Evidence for one model is evidenced against the other model. We've now seen 3 evidences to support a young solar system. We've seen recession of the moon. We've seen comets. We shouldn't have either long period or short period comets. We've seen the age of the sun refutes an old solar system. Let's look at 2 more. Supernova remnants and galaxy formation. Now, supernova remnants. First of all, what is a supernova? What happens? Well, it's when a star explodes. Now, here's the process. When a star is forming, when a star is doing a thermonuclear fusion, what is happening? It's converting hydrogen into helium, then into carbon, then eventually into oxygen, then eventually into iron, and that's where the fusion process stops. It doesn't go beyond iron. And at that point, the fusion process stops, and that star begins to gravitationally collapse in on itself, and it triggers a tremendous explosion called a supernova. Now, what is a supernova remnant? That is the leftover gas and dust cloud from that tremendous explosion. Now, we have observed some of these supernova remnants. In 1054 AD, the Chinese saw one in the sky that lasted for almost a whole month. It was as bright as Venus out there. In 1604, Galileo and Kepler saw a supernova. Even in the 1980s, we observed another supernova. So we have observed these stars exploding. We know that happens. But how does this apply to the age issue? Well, one of the things we do with these supernova remnants, again, these gas and dust clouds, is we divide them up into stages. First, second, and third stages. Now, what we mean by these stages is this. A first stage supernova remnant would be a star that has recently exploded. Maybe in the last few years to maybe several hundred years ago. We have the second stage supernova remnants. Those are the stars that may have exploded within the last maybe hundreds of years to maybe thousands and thousands of years. Then we have the third stage supernova remnants, which we classify as stars that have exploded in millions of years ago. Now, if this universe, this galaxy, solar system, is billions of years old, we should expect to see a number of these supernova remnants in each one of these stages. In other words, if the universe is billions of years old, we should expect to see at least 2 recently exploded stars or supernova remnants. If this universe is billions of years old, we should see about 2,260 second stage supernova remnants, ones that have occurred in the last hundreds of years to maybe tens of thousands of years ago. If this universe is billions of years old, we should see at least 5,000